Welcome to the Evolution demo. One of your tasks in this project will be to implement an arcade, which allows you to select between multiple different games to play. These include manual, smart, and multiplayer Flappy Bird, which you'll be implementing in this project, in addition to at least 2 other arcade games. Here we've implemented 4, Snake, Doodle Jump, Tetris, and a train cartoon. When we select a game, that game must have the option to quit the program, restart the game, or go back to the arcade's home screen. In addition, when you press the P key, the games must pause, and then unpause when you press the P key once again. The main focus of this project is to code manual Flappy Bird, then build a neural network that learns to play Flappy Bird by itself through a process called reinforcement learning, which you can learn more about in the handout. So the first checkpoint is to build manual Flappy Bird. In this case, we control the bird with the space key, the pipes scroll from right to left, and when we hit a pipe, the game ends, or when we hit the bottom of the screen, the game ends. You can also see at the bottom a stats bar, which contains the high score and the current score. In this case, the score is just the number of pipes that the bird has made it through. The next step in this project is to make Flappy Bird smart. As you can see here, the game plays itself, and when all the birds die, it automatically restarts and spawns in a new generation. The project uses evolution to pick the weights of the neural networks in each of these birds. Every generation, we pick the fittest birds and randomly mutate their weights to make the next generation. As you can see, it takes a few generations for birds to start knowing how to play the game, so we have buttons in the bottom right-hand corner to speed things up a little bit. In order for full functionality, you need to have a stats bar here at the bottom left that displays statistics about the game. As you can see, we have the number of birds alive in the current generation, the average fitness of the last generation, the best fitness of the last generation, the best fitness of all time, the current generation number, as well as the current fitness of this generation. Please note that the fitness of the birds doesn't actually correlate to their score. Rather, it relates to the total amount of time the birds have been alive. The goal of the project is to get the average fitness of the last generation to steadily increase as the birds learn. Sometimes we could have one bird that's really good, sometimes a bunch will be really bad, but the best marker of how your learning algorithm is doing is the average fitness of each generation. Additionally, sometimes one bird is really good, so we want to implement a kill switch into the program so that it doesn't keep going forever. In this case, we've implemented that kill switch at a current fitness of 200,000. At that point, all of the birds will die and a new generation will spawn in. We've added a few bells and whistles to this project, an infinitely scrolling background, some fun colors on the birds, and this improved arcade home screen. Feel free to go crazy with bells and whistles once you meet full functionality, and this can involve anything you can think of, including optimizing your fitness function, trying out different neural network architectures, or basically anything else you can come up with. Happy coding and have fun!